For exam review geometry, we're going to work on problems number 1, problem number 2. Try to make these videos as short as we can for your review's sake. Okay, question number 1. List the sides of the triangle from shortest to longest. Remember that if we have 3 angles in a triangle and they're not congruent, then the longest side is opposite the largest angle and the shortest side is opposite the smallest angle. And the vice versa works for that. If I have 3 sides of a triangle that are not congruent, then the largest angle is opposite the longest side and the smallest angle is opposite the shortest side. So we have that relationship happening. So in 1a, let's find our third angle measure. This is going to come from our triangle sum theorem. So I know that plus 37 plus angle P equals 180 degrees. So that means that angle P is equal. In terms of listing sides from shortest to longest, the smallest angle is 37, so the side opposite that is the shortest side. So that is side M. That is less than the next smallest angle, in this case is 63. Side opposite that is AM. That is, of course, is smaller than angle 80, the side opposite that, which in this case. Next problem. Again, we're only given 2 angles in a triangle, so we'll do triangle sum theorem. I know that 62 plus 58 plus angle T is equal to 180 degrees, meaning that angle T is equal to 60 degrees. In terms of listing the sides then, the smallest angle is 58, so the smallest side is TP. That is the smallest side. Next smallest side, angle 60, leaves me with side AP. And then, of course, the largest side is opposite the largest angle, so that's going to be side AT. Last problem. This means 90 degrees, so once again, triangle sum theorem gives us a third angle. 90 plus 36 plus angle A is equal to 180. So angle A is equal to 54 degrees. Now ranking the sides from smallest to largest. Smallest angle, 36, means the smallest side is AN. That is less than the next smallest side, which in this case, PN. And lastly, 90 degrees is our biggest angle, so the side opposite that is AP. Next, question number 2. Here we're listing angles from largest to smallest, so reversing the order there. 2A diagram is the same as 1A, so we know this missing angle P is 63. In terms of the angles, we can clearly just see. So the largest angle we visibly see is angle M. That is larger than the next angle, which is angle P, which is 63. And that is larger than the smallest angle, which is angle A, which is 2. Next problem. Here we're given 3 sides. We don't actually know the angles. Let's arbitrarily let x equal 2. So that means that this side is equal to 2. This becomes 2 minus 1, which is equal to 1. And this becomes 2 plus 3, which is equal to 5. So my side lengths are 2, 1, and 5. Well, we know the smallest angle is opposite the smallest side, and the largest angle is opposite the largest side. So I see the largest side of 5, which means the largest angle is angle T. Next biggest angle is opposite side 2. So that's angle P. And then the smallest angle is opposite the smallest side, so 1 small side giving me angle O as my smallest angle. Okay, 1C, last problem here. We're given all 3 sides, so the smallest side is opposite the smallest angle, and the largest side is opposite the largest angle. Largest side here is 15, meaning the largest angle is angle E. Next smallest side is 12, so that gives me angle B. And lastly, the smallest angle. It's opposite the smallest side, which is 9, which is angle F. That's it for question number 1 and number 2. That comes out of topic number 15, triangle inequality. We'll see a few more questions like that on questions number 7 and 8 in a moment. I'm going to jump to number 5 now, which comes out of topic 16, triangle midsegment. All right, question number 5, find the length of ML, the midsegment of the triangle. All right, so since they're telling us that this is in fact the midsegment of the triangle, we know 2 pieces of information from that. One, we know that ML is parallel to XZ, and additionally we know that ML is equal to half of XZ, or the more user-friendly version of this, XZ is equal to twice the length of ML. I think more user-friendly because I like to work with not fractions. It just makes the math a little bit easier. So, that being said, XZ we're given as X plus 23, and ML we're given as X plus 15, so 2 times X plus 15. I now have one equation in one variable, which I can go ahead and solve. X plus 23 equals 2X plus 30. Subtract X from each side. 23 equals 1X plus 30. Subtract 30, and I get X is equal to negative 7. Now again, it's okay for X to be equal to negative 7 here, as it is not a side length on its own, but within an expression. Would like to note that the things I'm highlighting in green here is actually just extra information meant to kind of mess us up. We need to focus on the midsegment and the base of the triangle. Okay, 5b. Again, we know that ML is the midsegment of the triangle, so that means that ML is parallel to CE. We also know that ML is equal to 1/2 of CE, or CE is equal to twice ML. And again, I'm going to use this version of the statement. So I'm given that CE is equal to X plus 29, and ML is equal to X plus 18. So again, one equation, one variable, I can go ahead and solve this. X plus 29 equals 2X plus 36. Subtract an X, 29 equals 1X plus 36. Subtract the 36, and I get again X equals negative. Now, that's how I find the missing value of X. I would like to make note that we need to go ahead and find the length of ML. We actually need to find the length of the midsegment in both of these problems. So I'm simply going to take this value of X and substitute it back into my expression for ML. So here then, ML is equal to X plus 15, or negative 7 plus 15, which equals 8. So ML is equal to 8, a midsegment. In 5a, in 5b, ML is equal to X plus 18. This problem I found is equal to negative 7 as well. So ML in this case is equal to 11.